Hello guys, in this video I am going to explain the solution to this question number 42 of the book of the chapter 13 from the book Engineering Circuit Analysis by Hayt, Kemmerly and Dublin. So the question says that we need to calculate the average power delivered to 400 milliohm and 21 ohm resistor, right? So we need to determine the power delivered to this, right? So in this, and over here we have a transformer having the, it is given turning ratio is 100. So A is 100. So in this particular question, how we can approach? First of all, we can determine, like we can determine what is our ZL. So our ZL, it is going to be the combination of these two, right? So it will be 21 plus this 400 milli ohm can be written as 0.4 ohm. So it will be 0.4 equals to 21.4 ohms, right? Once we get this, then we can determine the Zn. We can determine the Zn. So our Zn, it is going to be ZL upon A square. Means ZL is 21.4 upon 100 square. So this is our, let me keep it like this only, or 21.4 into 10 power minus 4 ohms. Now once we get this, then we know that the purpose of this Zn, it means that this part, this complete thing, it is replaced with Zn. Means now our circuit, it will be something like two right. Yes. Now it means we can determine the current I1. We can, or before I1 we can convert this voltage, which is V1, let it be V1, we can convert it into phasor form like this, 2 angle 0. So our V1, it is 2 angle 0. So we can now determine the current I1 as V1 upon, and the total impedance, it is 3 plus Zn. Now V1, it is 2 angle 0 and 3 plus Zn is 21.4 into 10 power minus 4, right? Now just to approximate, because this is very less than 3, so simply we can assume that 2 by I1 is 2 by 3 amperes, right? Because this this total, like it will be 3 plus, and since it is 0.4 10 power minus 4, so it will be 0.00214, means 3.00214. So we can approximate it as 3, right? Because 3 is very large in comparison to this 21.4 into 10 power minus 4, right? So over here I just approximate, so I get 2 by 3 ampere I1. Now once we get I1, so we can determine I2 as, with the formula that I2 will be I1 upon A, right? Because we know formula is I2 upon I1 is equals to 1 by A. So following this I1 come over here, so our formula, it become this. So I1 we know it is 2 by 3, A is 100. So our I2, it is 2 upon 300 amperes, right? Now once we get I2, now what we need to determine in the question? We need to determine the power delivered to this resistor and this resistor, right? So the power delivered, we know the formula is power will be equals to I square, means I2 square into R, right? So over here, if I want to determine the power, okay, and it is our average power, just a minute, yes, it is our average power that we need to determine. So the average power can be determined. Now over here, the power that we get, the power, this 2, it is Vm, right? This I2 that we get, it is Im. So it means if we need to determine the power, we know the formula for the power. It is average. It will be given as half Im square, right? Im square R. So we need to follow this. Over here, Im square, it is I2 square. So our formula, it will be Im means I2 square. I2 square into R upon 2. So over here, if we want to determine the power for the 21, so it will be half into I2. I2 is this 2 upon 300 square into 21, right? And P 0.4, it will be half 2 upon 300 into 0.4, right? So over here it is going to be like, if you solve this for the 21, so you will get 0.4665 4665 milliwatt. And for this you will get the answer as something as 8 by 9 into 10 power minus 5, or 0.009 milliwatt. So these are the two powers delivered to these two resistors. So this is the solution to this particular question. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.